Um, Hello everyone, good evening. So here we shall solve some more JEE Mains previous year questions on the chapter properties of matter. Any doubts if you have in any steps, please mention that in the comments so that we can give more clarity on it and solve more and more questions. We shall obviously clarify those doubts also. And in any other chapter of we physics, if you have more difficulty, then please mention the name of that chapter also in the comments. And please install our Sapience education application also, where we shall upload some important questions based on the previous year JEE Mains exam. So here it is told that a uniform heavy rod of weight 10 kg should be cross-sectional area 170 square and length 20 centimeter is hanging on a fixed support. So it is hanging from a fixed support. Area of cross section is 100 centimeter square, or I can say 100 into 10 power minus 4 meter square. So it is 10 power minus 2 meter square. And the length L, that is 20 centimeter, or I can say 0.2 meters. And the weight, that is the mass is 10 kg. Young's modulus of the material of the wire is 2 into 10 power 11 Newton per meter square. Then neglecting the lateral contraction, find the elongation of the rod into its own weight. So this delta L, which is the extension or the elongation of the rod, that we have to find out. So the weight of the rod is mg. And so I can say force, as we know, force that is equal to YA by L into delta L. So now force, that is mg is equal to YA by L into delta L. Now this delta L, that will be equal to mgl by A1. So therefore, delta L, that will be equal to this delta L, that will be mg 10 into g, we can take it as 10 into L, that is 0.2 divided by A, that is 10 power minus 2, and Y, that is 2 into 10 power 11 smudge meters. So this will be 2 into 0.1, that is 0.2. So this will be 1. So 10 power 1 plus 2 minus 11. So here actually delta L, we have the weight is acting from the midpoints, and the center of mass is at the midpoint. So therefore, we have to take the length L as 0.1 meter, which is half of it. So therefore, actually wrong. This is mg into L it is 0.15. Half of the length we have to take. Since the weight is acting from the midpoint of the rod, since it is told that it is a uniform rod, the A that is 10 power minus 2 into times modulus that is 2 into 10 power 11. So this will be 10 power 1 plus 2 minus 11 divided by 2, which is half into 10 power 3 minus 1, that is minus 8. Is 0.5 obviously. It is equal to 5 into 10 power minus 2 5s are 10. 2 5s are 10. It is going 5 into 10 power minus 9 meter. So it means none of the answers are correct. The weight should be 10 kg meter per second square. Okay, kg meter per second square to take. Kg meter per second square only you have to take. Since we know that kg meter per second square is Newton only, so the weight is 10 Newton. So the value of mg is only 10 Newton. This we don't have to pay. So it means this will be 10 into 0.1 divided by a into 1. So this will be now 1. 1 by 2 into 10 power 2 minus 11, which is 0.5 into 10 power minus 9, which is 5 into 10 power minus 10 meter. So option D is the correct answer. Then it is told in Millikan's oil drop experiment, what is viscous force acting on an uncharged drop of radius 2 into 10 power minus 5 meter and density 1.2 into 10 power 3 kg per meter cube. In Millikan's oil drop experiment, what is the viscous force acting on an uncharged drop of radius? It's the radius of the drop is 2 to 10 power minus 5 meters. The density rho, that is 1.2 into 10 power 3 kg per meter cube, and viscosity of the liquid, which is eta, the coefficient of viscosity, which is 1.8 into 10 power minus 5 Newton second per meter square. Then neglect buoyancy due to air. So the viscous force acting on, which is acting vertically upwards, the downward force is the weight, and it is told that we have to neglect the buoyancy due to the air. So it means the viscous force will be equal and opposite to the weight, that is mg. and charge drop is here, which is of the radius. So it is inside the liquid, I mean density sigma. So therefore, the buoyancy of the liquid will obviously act is V sigma G. So therefore, viscous force plus the buoyancy force is V sigma G, that is going to be everything. So therefore, the viscous force that will be nothing but V mg minus V sigma G. Now the volume we can tell that is mass by density. That means the viscous force that will be equal to mg minus mg into sigma by rho, which is mg into 1 minus sigma by rho. Now, therefore, the mass of the oil drop, that is equal to 4 by 3 pi r cube into rho is, sorry, g is not there. Since mass is volume into density, which is 4 by 3 into pi 3.14 into r cube, that is 2 into 10 power minus 5 whole cube into rho. Your so here actually mg only will be there, since why the outside there is air only and the buoyancy of the air we have to neglect. So therefore the viscous force will be equal to mg, which is 4 by 3 pi r cube into rho into g. Into rho, that is 1.2 into 10 power 3. Therefore, the viscous force that will be equal to 4 by 3 pi r cube into 10 power minus 5 whole cube into rho 1.2 into 10 power 3 into g, that is 10. Now, into 3 4s are there, 0.4, so 4 4s are 16, 1.6 into 3.14 into this will be equal to 8 into 10 power minus 15 plus 4, which is 0.48, 12.8 into 3.14 into 10 power minus 11, this much Newton. Now I can say 1.28 into 3.14 into 10 power minus 10 Newton. So this will be 1.2 into 3.94, which is 3.8 approx. 3.8 into 10 power minus 10 Newton. Means it is coming 3.77 approx. 3.77 into 10 power minus 10, which is approximately, you can take 3.8. 3.8 into 10 power minus 10 Newton, or you can take 3.9 also, 3.9 into 10 power minus 10 Newton. So of course, option B is the correct answer. Here it stores two blocks of masses 3 kg and 5 kg. connected by a metal wire going over a smooth pulley. Two blocks of masses 3 kg and 5 kg are connected by a metal wire going over a smooth pulley. The breaking stress of the metal is 24 by pi into 10 power 4 Newton per 10 power 2 Newton per meter square. And what is the minimum radius of the wire? The breaking stress is there. So now we know that here how much tension force is acting. The thing is here 50 Newton is acting here 30 Newton is acting. So here there is tension force. If there is tension force, we can say now therefore the acceleration of the system, that will be 50 minus 30 by 5 plus 3. This is the acceleration. So acceleration will be 20 by 8. 4 is 8, 4 5 is 20, which is 2.5 meter per second square. Now we can say that t minus 30, that is equal to 3a, 3 into 2.5. So therefore t will be equal to 15, 7.5, so it is 37.5 Newton. Therefore, here it is told the minimum radius, it means the breaking stress means sigma should be less than or equal to the breaking stress, sigma dr. Now, the stress that is given as the tension force per unit area, that should be less than or equal to 24 by pi into 10 power 2. Now, the tension force is 37.5 divided by A, that is pi r square. Pi r square, that should be less than or equal to 24 by pi into 10 power 2. Now, pi I can cancel out, and this will be 3 12 are 20, 3 8 are 24, and then 3 1 are 3, 3 is 6, 3 5 is 15. So therefore, it is coming that 4.5 divided by r square, that is less than or equal to 8 into 10 power 2. It means r square should be more than or equal to 12.5 by 800. Means this r square should be more than or equal to 125 by 8,000. With 5, I can cancel out. And 5,025, 5 ones of 5, also is 30, 1600. So therefore, R should be more than or equal to square root of this, which is 5 by 40. 5 8s are 40, so R should be more than or equal to 1 by 8. Therefore, the minimum radius of the wire, that should be 1 by 8 meters, or I can say 100 by 8 centimeter, which is 4 to the 8, 4.5 is 100, so 12.5 centimeter. 12.5 centimeter is the minimum radius of the wire. So option C is the correct answer. And here it is told two narrow pores of diameter 5 millimeter and 8 millimeter are joined together to form a U-shaped tube which is open at both ends. It's formed to form a U-shaped tube which is open at both ends. Okay. If this U2 contains water, what is the difference in the level of the two limbs of the tube? Take surface tension of water this, angle of contact is 0, and G is 10 geometry water. So two poles, they are connected to form a U-shaped tube. One is having larger diameter, and one is having smaller diameter. Now its radius, which is 4 millimeter, and its radius is 2.5 millimeter. Now here the height, here the height h1, and here the height will be h2. So now if the radius is more, then the height gained will be lesser. Since we know that height, which is the capillary rise, height, that is the capillary height gain is the capillary rise, that is given as h equal to 2t cos theta 2s cos theta by agr, where s is the surface tension. H1, that will be equal to 2s cos theta by rho g r1, and H2, that will be equal to 2s cos theta by rho g r2. Therefore, now the difference in the level of the two limbs of the tube, H1 minus H2, that is 2s cos theta by rho g, which I can take as common, that into, you can say 1 by r1 minus 1 by r2. So this radius is given in centimeters. So r1, that you can write, r1 is 2.5 into 10 power minus 3 meter. Similarly, R2 will be 4 into 10 power minus 3 meter. So this will be 2 into S. Now theta is 0, since it is told the angle of contact is 0. So cos 0 will be 1. And then so 2 into S surface tension, that is 7.3 into 10 power minus 2 by rho, the density, that is 10 power 3 into G, that is 10, into 1 by R1, which is 2.5 into 10 power minus 3, minus 1 by 4 into 10 power minus 3. So this 10 power 3 will come outside. This will come 2 into 7.3 into 10 power will be minus 2 into 10 power 3 divided by 10 power 4 into, this will be 1 by 2.5 minus 1 by 4. So this will cancel out. So this is 2 into 7.3, which is h1 minus h2, that is 2 into 7.3 into 10 power minus 2. No, this will be minus 3 into 1 by 2.5, means you can say 10 by 25 minus 1 by 4. So this will be 5 to the 10, 5 to the 25. So this will be 0.4, 2 0 6, which is under 14, 14.6 into 10 power minus 3 into, this is 0.4 is 0.4 minus 0.25. So this will be 14.6 into this will be 0.15 or minus 3 meters. So this will be 14.6 into 0.15 millimeter. This will be equal to 2.19 millimeter. Option B is the correct answer. Then here is told a raindrop with radius 0.2 millimeter and 0.2 to 10 power minus 3 meter. It falls from a cloud at a height of 2000 meter above the ground. Assume that the drop is spherical throughout its path and the force of buoyancy force or buoyancy may be neglected, then the terminal speed attained by the drop is. So when the terminal speed will be attained, then we can say the viscous force that will be equal and opposite to the weight, which is mg. Since we here we have to ignore the buoyancy force. So therefore, viscous force that is equal to mg. Now, viscous force that is given as 6 pi eta rv that is equal to mg, which is 4 by 3 pi rq into rho into g. Rho is the density of water, density of the water that is rho. Eta is the quotient of viscosity of the air. So pi and pi will cancel out. 2 3 are 6, 2 2 are 4. R and R square will get, and we will get 3 eta v that is equal to 2 r square rho g by 3. So therefore, v that will be equal to 2 r square rho g by 9 eta. Therefore, the terminal velocity that is 2 into r square, which is 2 into 10 power minus 4 whole square into rho that is 10 power 3 into g that is 10, g that is 10 divided by 9 into eta. Eta is 1.8 into 10 power minus 5. We simplify it, then we get for the A 8 into 10 power minus 8 plus 4 plus 5 divided by 9 into 1.8. So this will be equal to 80 by 9 into 1.8. It's much meter per second. It's 9 into 1.8 is 16.2. So therefore the terminal velocity that is approximately 80 by 16.2 18 by 16.2 meter per second, which is approximately 16,580, so 4.94 meter per second. So option C is the correct answer. And here it is told a light cylindrical vessel is kept on a horizontal surface. Area of the base is A. A hole of cross-sectional area small a is made just at its bottom side. The minimum coefficient of friction that is necessary to prevent sliding the vessel due to the impact force of the liquid is the area of which the minimum coefficient of friction necessary Given the vessel due to prevents sliding the vessel due to impact force of the emerging liquids. So, so here the frictional force will act like this, that is equal to mu times n. Here n would be equal to mg. Let's say the height is h. Therefore, mass will be volume ah into density, that is rho. It is area in this whole water will come outside. Let's say the velocity that is v1 here and the velocity with which it will come out, that is v2. So a into v1, that is equal to small a into v2. Therefore, now v2 that is equal to a v1 by a. Now we can apply the Bernoulli's principle also, that the outside pressure is P naught, which is atmospheric pressure P naught. So P naught plus half rho v1 square plus rho gh1 h, that is equal to, let's say the hole is at a height 0, which means it is at the ground level. That is equal to P naught plus half rho v2 square plus 0. P naught will get cancelled. So you can say rho gh, that is equal to half rho into v2 square minus v1 square. So rho and rho will get cancelled. So when this will come out, v2 with the velocity v2, then there is a volume flow rate. Now the force that is equal to dp by dt, which is the change in momentum tmv by dt. Velocity is constant, so it will be dm by dt, and m is rho into volume. So velocity into v2, v is v2 here. So v2 into rho into d volume by dt. Your dv by dt, I can say dv by dt is a into v2, which is also same as a into v1. So therefore, I can say this will be the force that is applied, that is rho v2 into a into v2. Is rho into small a into v2 square. This is 2gh, that is equal to v2 square minus v1 square. Is a v1 by a whole square minus v1 square. So v1 square into a square by a square minus 1, that is equal to 2gh. Now friction should be equal and opposite, which is force, which is mu times n. Therefore, mu times mg is A into H rho into G. Mu and G. And that should be equal and opposite to this force, which is rho A V2 square. Now this minimum value of coefficient of friction that we have to find out. Now V2 square, that is equal to A V1 by A whole square. It is A square by A square into V1 square, which is A square by A square into V1 square, that is 2GH by A square by A square minus 1. So to 2GH by 1 minus A square by A square. So this is V2 square. Therefore, I can say mu into AH rho G, that is equal to rho A into 2 square, which is 2GH by 1 plus 1 minus A square by A square. So now rho will cancel. H will also cancel. G and G will also cancel. So mu is coming 2A by A to 1 minus A square by A square power minus 1. Now this value means A is much less than A, we can assume. So A square by A square is much less than 1. So this 1 minus A square by A square, we can take it approximately 1. So therefore, mu will be approximately equal to 2A by A. So mu will be 2A by A. And if we can't tell this, then the answer will be none of these. But here we can assume that the area of cross section of the hole is much less than the area of uh, the area of cross section of the light cylindrical vessel. So therefore, the answer is 2A, 2 small a by capital X. So option C is the correct answer. So here it's told that two spherical soap bubbles of radii R1 R2 in a vacuum combined under isothermal conditions. The resulting bubble under radius equal to. Under isothermal conditions, if they combine, then we know that uh, pressure into volume that will be constant. So therefore, the pressure inside the first soap bubble, that will be V naught plus 4s by R1. So uh, into the volume, that is 4 by 3 pi r1 cube. Pressure into volume, that is constant. So yeah, pressure into volume, that is constant. So we say that is 4s by r1. 4s by r1 into 4 by 3 pi r1 cube plus this way. If we take a bubble, then if the outside pressure is P naught, then the pressure inside, that will be P naught plus 4s by r if the radius is r. So we have to use P1 V1 plus P2 V2 is equal to P3 into V, where V is the volume of the large spherical drop which is obtained, the volume of the large spherical soup which is obtained when the two small uh, bubbles will combine under isothermal conditions. So here two bubbles will combine under isothermal conditions and a new large soap bubble will be formed. Then we have to find the radius of the large soap bubble. So this will 4s by r1 into 4 by 3 pi r1 cube plus 4s by r2 into 4 by 3 pi r2 cube, that is equal to 4s by r into 4 by 3 pi r cube. Then this radius r that we have to find out. So we can cancel out this 4s into 4 by 3 pi. 4s into 4 by 3 pi we can cancel out. So therefore we can say this will be r1 square plus r2 square, that is equal to r square. Therefore r will be equal to square root of r1 square plus r2 square. Option C is the correct answer. So here it has been told that two wires of same length and radius are joined end to end. Two wires are having same length and same radius, they are being joined end to end. The Young's moduli of the method of the two wires are y1 and y2. We can combine the combination behaves as a single wire, then its Young's modulus is. So here the force that is applied. So here the net extension that will be equal to delta L1 plus delta L2. Now delta L that is equal to F force by A, which is y A by L. So your cross section is A and its length will be, they are having same radius and its length will be 2L, y by 2L, that is equal to F by y A by L y1, which is plus F by y2 A by L. So this means F by AL that will get cancelled. So there here we will get 2 by y, that is equal to 1 by y1 plus 1 by y2. So therefore 2 by y that is equal to y1 plus y2 by y1 y2. So therefore y by 2, that is this y will be equal to 2y1 y2 by y1 plus y2. So this is the Young's modulus of the combination of the two pairs. So option B is the correct answer. The length of a metal wire, length of a metal wire is L1 when the tension in it is T1 and is L2 when the tension in it is T2. The natural length of the wire is. So here the if the natural length is suppose L0 or I can say L only. So then here the extension that is delta L1 that is L the extension that is L1 minus L and here the extension the second case that is L2 minus L. I can say T1 will be equal to YA by L into delta L which is L1 minus L. Similarly T2 will be YA by L into L2 minus L. So therefore now T1 by T2 that will be equal to L1 minus L by L2 minus L. Now therefore you can cross multiply. So then it will be T1 into L2 minus L that is equal to T2 into L1 minus L. So then this will be T1 L2 minus T1 L is equal to T2 L1 minus T2 L. So therefore I can say L into T2 minus T1 that will be equal to T2 L1 minus T1 L2. So this will be equal to L will be equal to L1 T2 minus L2 T1 by T2 minus T1. It means the natural length is this option D is the correct answer. Here it is told two small drops of mercury, each of radius r, coalesce to form a single large drop. The ratio of the total surface energy before and after the changes. So the total surface energy that is given as the surface tension into the surface area. So the initial surface energy before the change that will be equal to the surface tension into the total surface area which will be 4 pi r square into 2 since two small drops are there. The final surface energy which is after the change that will be the surface tension into 4 pi r1 square where r1 is the new radius of the large single drop. Now here, so when the two large drops will be combined, then the final and the initial volume will be same. Since we have to apply the law of conservation of mass. Since density is same, so the volume will remain unchanged. So I can say 4 by 3 pi r cube into 2, that is equal to 4 by 3 pi r1 cube. 4 by 3 pi 4 by 3 will cancel. So r1 that is equal to 2 power 1 by 3 r. So therefore the final surface energy, that is P into 4 by 4 pi r squared, that is 2 power 2 by 3 into r squared. So now therefore the ratio of the total surface energy before and after the change means P initial by E final, that we have find. So T into 4 pi r square into 2 divided by T into 4 pi r square into 2 power 2 by 3. So this 2 will get cancelled. So it will be 2 by 2 power 2 by 3, or I can say the 2 power 1 minus 2 by 3, that is 2 power 1 by 3 by 1. Because 2 power 1 by 3 is to 1. So option A is the correct answer. And it is told the value of tension in a long thin metal wire. There is a long thin metal wire. The value of its tension has been changed from T1 to T2. The length of the okay, length of the metal wire at two different values of tension T1 and T2 or L1 and L2 respectively, then the actual length of the wire is. L1 and L2 are the lengths. So if the natural length is L, then I can say T1 will be equal to YA by L into delta L, which is L1 minus L, and T2 will be also YA by L into L1, L2 minus L. Therefore, if we divide these two, then we will get T1 by T2, that is equal to L1 minus L by L2 minus L. Then from here, L I have to find out. L I have to find out. But then this will be T1 L2 minus T1 L, that is equal to L1 T2 minus T2 L. So therefore, T2 minus T1 into L, L1 T2 minus L2 T1 by T2 minus T1. Or we can say L will be T1 L2 minus T2 L1 by T1 minus T2. That also is true. So option C is the correct answer. Then here it is told an object is located at 2 kilometers beneath the surface of the water. The object is located at 2 kilometers beneath the surface of the water. If the fractional compression is delta V by V, The fraction compression delta V by V is 1.36%. Then the ratio of hydraulic stress to the corresponding hydraulic strain will be ratio of the hydraulic stress to the hydraulic strain, which is force delta A means pressure by delta V by V that we have to. It means the bulk modulus we have to find out. We have to find the bulk modulus, which is the ratio of the hydraulic stress to the corresponding hydraulic strain. So the pressure, that is the delta P, that is 2 kilometers beneath the water surface. So therefore the pressure is P naught plus rho GH. P naught is 10 power 5, or I can say rho, here P naught has not been told. So rho GH density is 10 power 3, G is 9.8 into H, that is 2 kilometers, so 2 into 10 power 3. This will be 2 9 18, 19.6 into 10 power 6. And delta V by V is 1.36%. So therefore, the bulk modulus, that is 1.96 into 10 power 7 divided by 1.36 by 100. Which means it is 1. Which means the bulk modulus, that is 1.96 by 1.36 into 10 power 9 Newton per meter square. Now this value 1.96 by 1.36, that is approximately 1.96 divided by 1.36, that is 1.44 approx. Therefore, the bulk modulus, that is approximately 1.44 into 10 power 9 Newton per meter square. So option D is the correct answer. So then when two others of radii A and B coalesce, the radius of curvature of the common surfaces. If they will coalesce, what will happen when okay, so B is more than A, so one of them is having more radius, which is B. This is having radius A. So now here the radius is higher, so the pressure is lesser. So let's say this is P1, outside pressure is P naught, here pressure is P2. So now the radius of curvature of this common surface that we have to find out. So that will be suppose radius R. Now we can say that P2 minus P1, that is equal to 4s by R, and P1 minus P0, that is equal to 4s by B, where S is the surface tension of this soap, and P2 minus P0, that is also equal to 4s by E. Now, if we subtract these two, then we'll get P2 minus P0 minus P1 plus P0, that is equal to 4s by A minus 4s by B. And that is obviously equal to 4s by R. So therefore, we can see 4s by A minus 4s by B, that is equal to 4s by R. Now 4s I can take as common and I can cancel out. So 1 by A minus 1 by B, that is equal to 1 by R. So therefore, if you take LCM, that is AB, and this is B minus A, that is equal to 1 by R. So therefore, the radius of curvature of the cone surface is AB by B minus A. Option D is the correct answer. And here it is told that what will be the nature of flow of water from a circular tap when its flow rate increased from 0.18 liter per minute to 0.48 liter per minute. So what will be the nature of flow of water from a circular tap when its flow rate increased from 0.18 liter per minute to 0.48 liter per minute? The nature of flow of water from a circular tap. This is the volume flow rate. The radius of the tap. So the radius of the tap, that is 0.5 centimeter. It means I can say it is 0.5 into 10 power minus 2 meter, or 5 millimeter, which is 5 into 10 power minus 3 meter. The density of the water, that is 10 power 3 kg per meter cube, and the coefficient of viscosity, that is 10 power minus 3 Pascal second. So now therefore we know that the volume flow rate is dV by dt, that is given as pi, nature of flow that we have to find out, pi p r power 4 by 8 theta l, pi p r power 4 by 8 theta l. Now Reynolds number, can call this radius small r. So the Reynolds number that is given as rho v t by eta, rho v t by eta. Now actually dv by dt, the volume flow rate, that is given as area of cross section into the speed, that is the velocity. area of cross section, I can say it is pi r square into b. The volume flow rate we have to use it. Now, the volume flow rate that is given in liter per minute, but we have to convert it into meter cube per second. So now it means 1 liter per minute. I can say it is 10 power minus 3 meter cube. Since 1 meter cube is 1000 liters, and that by 60. This much meter cube per second. So now, therefore, this is the volume flow rate in E rho V d by eta, which is the Reynolds number. Reynolds number. Now, therefore, we can say R1. So the rule is that if the Reynolds number is less than 1000, then the flow is a steady flow. And if R is more than 1000 but less than 2000, then it is uh, flow becomes unsteady, and the flow uh, becomes unsteady. And then if R is more than 2000, then it is a turbulent flow. Is a turbulent flow. But then, so here the initial value of the Reynolds number that we have to find first. So we have found out that 1 liter per minute, that is equal to 10 power minus 3 by 60 meter cube per second. Since everything we have to use it in the SI units. So the Reynolds number initially, that is rho, that is 10 power 3 into V, that is 0.18 into 10 power minus 3 divided by 16 into d, d by eta. D is the uh, uh, d is the d is equal to 2r, which is the diameter of the tube, the diameter of the tube. So that will be 2 into 5 into 10 power minus 3 meter, which is 10 power minus 2 meter. So it's 10 power minus 2 by eta, which is 10 power minus 3. So these two will get cancelled. Now 6 10s are 60, 6 3s are 18. So this will come, 10 power 2. So this will be 0.03. Our initial, that is density 10 power 3 with volume flow rate 10 power minus 3 by 60. D, that is 10 power minus 2 meter by eta, that is 4 minus 3. Rho is 10 power 3 kg per meter cube. B is 0.18, 10 power minus 3 by 60 into D, that is 10 power minus 2 is 5 centimeter, 5 centimeters. So 10 power minus 2, 66, 3 by 18, 0.03, power minus 3 is there, 10 minus 2 will get cancelled. So this will become 0.03 only. Now the final value of the Reynolds number, that will be also rho GP by eta, this 10 power 3 into 0.48 into 10 power minus 3 by 60 into t, which is 10 power minus 2 by eta, which is 10 power minus 3. So these two will get cancelled. 6 minus 66 8 of 48. So this will get cancelled. So this is 0.0. So in both cases, the Reynolds number value is less than 1000 only. So the flow will remain steady. So it will remain steady. So option D is the correct answer. The pressure acting on the submarine is 3 into 10 power 8 Pascal at a certain depth. If the depth is doubled, the percentage increase in the pressure acting on the submarine would be. We know that a certain depth pressure is this. So the atmospheric pressure is 10 power 5. So 3 times the atmospheric pressure, that is equal to P naught plus rho g h. Suppose, so it means rho h is actually 2 P naught by rho g. Now if the depth is double, it means the new height, the new depth h dash, that is 4 P naught by rho g, which is 2h. So then the percentage increase in the pressure acting on the submarine GPU means then delta P by P into 100%, that you have to find out the percentage increase in the pressure. So the percentage increase in the pressure. So now H dash is this. So therefore now the new pressure. So this is the initial pressure, which was actually supposed P, which was 3 into 10 power 5 Pascal at a certain depth, and P dash, that will be equal to P naught plus rho g into H dash. So that will be P naught plus rho g into 4 P naught by rho g. That is 4 P naught plus P naught, that is 5 P naught. So therefore, the increase in the pressure, that is P dash minus P by T into 100%. So that is 5 P naught minus 3 P naught divided by 3 P naught into 100%. So that is obviously 2 by 3 into 100, which is 200 by 3, that is 3618. Or percentage, I can say it is 200 by 3%. So this is the required percentage increase in the pressure acting on the submarine. So option B is the correct answer. And here it is told the length of a metallic wire is L1 when the tension is T1, it is L2 when the tension is T2, then the original length of the well, so which we have already solved. So if the original length is L, then if the T1 is the tension and the length is L1. So then I can write T1 is equal to Y equal L into L1 minus L. Since L1 minus L will be the amount of extension in the metallic wire. Similarly, T2 I can say that is YA by L into L2 minus L, where Y is the Young's modulus, A is the area of cross section, and L is the length of the wire. So therefore, if you take the ratio that is T1 by T, that is equal to L1 minus L by L minus L. Now if we cross multiply it, then I will get T1 L2 minus T1 L, that is equal to T2 L1 minus T2 L. And now therefore I can say this will be T2 minus T1 into L, that is equal to T2 L1 minus T1 L2. So therefore L that will be equal to T2 L1 minus T1 L2 by T2 minus T1. It means that option B is the correct answer. A large number of water drops, each of radius r, combined to have a drop of radius capital R. If the surface tension is T and the mechanical equivalent a large number of water drops, each of radius r, they will combine to form a drop of radius r. If the surface tension is T and the mechanical equivalent of heat is G, the rise in heat energy per unit volume will be. Now, therefore, the change in the surface energy that will be obtained as heat change in the surface energy that will be obtained as heat. Now, so therefore, the heat energy that is delta Q, I can say, that will be equal to J times the surface, the change in the work done, the J into the work done to in decreasing the surface area. So which is equal to J times into T delta A, where delta A is the change in the surface area. The change in the surface area that will be equal to the initial area minus the final area. So the initial area that is equal to N into 4 pi r square minus 4 pi capital R square. Now, a large number of water drops is combining. So the rise in heat energy per unit volume that we have to find out. Rise in the heat energy per unit volume. It means delta Q by 4 by 3 pi r cube into N into 4 by 3 pi r cube. So that we have to find out. So now here the volume will be obviously same. The initial volume and final volume will be same. Since if we apply the law of conservation of mass and the density is same, so the initial volume and final volume will be same. So I can say N into if there are N water drops, then I can say that N into 4 by 3 pi r cube that is equal to 4 by 3 pi capital R cube 4/3 capital R cube. 4/3 4/3 will get cancelled. So R will be equal to n power 1/3 into R. N power 1/3 into R. So therefore, the change in the surface area that will be equal to n into 4 pi R square minus 4 pi into capital R square, which is R square into n power 2/3, which will be 4 pi R square n into 4 pi R square into 1 minus the second right n by n power 1/3. So it is 1 by n power 1/3. So therefore, we have to find delta Q by n into 4/3 pi R cube, which is the heat energy per unit volume. So that is JT into delta A, which is actually n into 4 pi R square minus 4 pi capital R square divided by delta Q, that will be delta W by J actually. Delta W by J. So this by J is divided. J is the mechanical equivalent of heat. Is divided by J. So from here I can say that N is equal to actually R cube divided by R cube. N is R cube by R cube. It's capital R cube by small r cube. This by N into 4/3 pi R cube. This will be 3 T by J into N 4 pi R square minus 4 pi R square divided by N into 4 pi R cube. So that will be 3T by J into this will be 1 by R minus this will be 4 pi will cancel R square by N R cube. Now N R cube that is equal to R, which is equal to capital R cube. So this is capital R cube. So I can say this is 3T by J into 1 by R minus 1 by R. So this is the heat energy per unit volume. So it means option B is the correct answer. And here it is told the normal density of a material is rho and its bulk modulus and velocity is k. The magnitude of increase in the density of the material when a pressure P is applied uniformly on all sides will be. So now the bulk modulus, which is K, that is given as the pressure applied by dV by V. Now, since the mass of the substance is volume into density and that is constant, so I can say if we differentiate those sides, then we get rho dV plus V d rho, that is equal to 0. Since why? Since change in the mass is 0. Obviously, dm equal to 0 only. So I can say rho dv that is equal to minus v d rho. So it means that d rho dv by v that is equal to minus d rho by rho. Or I can say minus dv by v is equal to d rho by rho. So here also this I can say p by d rho by rho. So the magnitude of increase in the density that we have to find out, d rho that we have to find out when a pressure P is applied. So therefore from here we can say see that K is equal to P rho by T rho. That means that d rho that is equal to P into rho by K, or you can say rho P by K. So rho P by K that is actually the magnitude of the increase in the density of the material. Option C is the correct answer. Here it is told if y, k, and eta are the values of the Young's modulus, bulk modulus, and the modulus of rigidity of any material respectively. Choose the correct relation for these uh, parameters. Correct relation for these uh, parameters. Now the rule is y is equal to 3k into 1 minus 2 sigma. Y equal to 3k into 1 minus 2 sigma. This we have to know it. The Young's modulus that is equal to 3 times the bulk modulus into 1 minus the modulus of rigidity. The sigma is called the Poisson's ratio. Sigma is the Poisson's ratio. Also, y is equal to eta into y plus sigma. Y is equal to also 2 eta into y plus sigma. But sigma is called the Poisson's ratio. It is the ratio of the lateral strain by longitudinal strain. Lateral strain by longitudinal strain. So now, sigma, from here you can see 1 minus 2 sigma that is equal to y by 3k, and 1 plus sigma that is equal to y by 2 eta. Y by 2 eta. Now from here we can see that 2 sigma that is equal to 1 minus y by 3k. And from here sigma that is equal to 1 minus y by 2 eta. Therefore I can say twice of 1 minus y by 2 eta that is equal to 1 minus y by 3k. Therefore, Young's modulus that we can find. So therefore, 2 minus 2y by 2 eta that is equal to 1 minus y by 3k. So therefore, y into 1 by eta minus 1 by 3k that is equal to actually 2 minus 1 that is 1. So therefore, y will be equal to 3k eta divided by pk minus eta. So this is actually 2y by 2 eta minus 1. Y by 2 eta minus 1. So this will be y2y by minus 2. So this will be y by y into 1 by eta plus 1 by 3k, that is equal to 1 plus 2, that is 3. This will be 3 into 3k eta, that is 9k eta divided by 3k plus eta. And y and eta, if you want to find, again that will be from here k also you can find. From here I can say sigma is equal to 1 by 2 into 1 minus y by 3k. That is also equal to y by 2 eta minus 1. Therefore, I can say that 1 by 2 minus y by 6k, that is equal to y by 2 eta minus 1. Therefore, I can say y by 6k, that is equal to half plus 1 minus y by 2 eta. So therefore, this should be 3 by 2. So y by 6k, that is equal to 3 by 2 eta, and this will be plus 3 eta minus y. Therefore, k by 6k by y, that is equal to 2 eta by 3 eta minus y. Therefore, 2, 3 or 6, I can write that is the k will be equal to eta y by 9 eta minus 3y. So 9 eta minus 3y, this much Newton per meter square. So obviously option B is the correct answer. So hope all of you understood the solutions of all these questions based on the previous year JEE Mains exam on the chapter properties of matter. Still any doubts if you have, please write that in the comments. We shall obviously clarify them in the subsequent videos, and also in any other chapter of physics. If you have more difficulty, then please mention the name of that chapter also in the comments, so that we can give more priority on it and solve more and more questions of that chapter. Also, please install our Sapience education application, where we shall upload some important homework questions on every chapter of physics, which will be obviously helpful for your exam. So the link of the Sapience education application has been provided in the description. So thank you everyone. Bye.